You know, in programming, one of the first things they tell you is to avoid global variables at all costs. But here's the thing. Most of our systems are built around the biggest global variable you can imagine, the database. So today, we're going to dig into this really powerful idea that just flips that whole concept on its head, turning the database completely inside out.
And this quote from Martin Kleppmann, it just hits the nail on the head. We spend so much time avoiding global mutable state in our code, right? Because we know it's a recipe for disaster, things like race conditions and deadlocks. And yet, our entire system architecture often ends up revolving around this one giant global variable. So what if we could actually change that?
So here's how we're going to break this all down. First, we'll really nail down why the traditional database model is a problem. Then, we'll get into the core idea of turning it inside out. We'll look at a real-world example of how Netflix did this, dive deep into their incredibly clever watermark solution, and then finish up by looking at the rock-solid technology that makes all of this even possible.
All right, let's kick things off with our first section, the database as a problem. I mean, why is this thing we rely on so heavily also the source of so many of our biggest architectural headaches?
Okay, so this probably looks super familiar to a lot of you. It's the standard playbook. We build our app servers to be stateless, and that's great for scaling, right? You just spin up another one. But all that state, all that memory, it has to live somewhere. So we push it all into one big, central, stateful database. And what happens? Every single server is hammering that one database, creating a massive bottleneck.
Now, this is where it gets really interesting. On the left, you've got the classic textbook problem of multiple threads fighting over the same variable in your code. We've come up with all sorts of clever patterns to avoid that mess. But look at the right. All we've done is taken the exact same problem and blown it up to the entire system level. The database is our shared memory, and we're just recreating those same nasty concurrency issues on a much, much bigger scale. Okay, so if the shared mutable database is the problem, what's the fix? Well, that brings us to our core concept for today, turning the database inside out. This is a huge shift in thinking. It's about moving from data as something you constantly change to data as an unchangeable history of things that happened.
And this slide just lays it out perfectly. The old way is a command, right? You're telling the database, update this row. You're ordering it to mutate its state. But the new model, it's just a fact. It's a statement. This event occurred. And that fact is immutable. It can't be changed. Even if the customer changes the quantity again later, the original fact that they once changed it from 1 to 3 is true forever.
So here's the bottom line. A traditional database overwrites data. It effectively destroys history. Poof, the old value is gone. But this stream-based approach, it just adds new events to the end. It creates this complete, permanent, auditable log of everything that has ever happened. You're not just looking at the present anymore. You have the entire history.
All right, I know this might sound a little bit out there, so let's ground it in reality. We're going to look at a real-world system from Netflix called dblog. They had to figure out how to put this database as a stream idea into practice, and they had to do it at Netflix scale. And the magic that makes this all possible is a technology called Change Data Capture, or CDC. See, instead of constantly polling the database tables, which is slow and inefficient, CDC systems tap directly into the database's internal transaction log. That's the same log the database itself uses for things like replication and recovery. It lets you see every single committed change, in the right order, the instant it happens. So here's the 10,000-foot view of how dblog works. It's actually pulling from two places in the database: the live change log for all the new stuff, and the tables themselves to get the full historical state. It uses something like Zookeeper to keep track of where it is, and then it masterfully merges those two sources into one single, unified output stream.
So you might be asking, why did Netflix go through all the trouble of building their own thing? Well, this table tells the whole story. The existing tools just didn't cut it. Some of them would actually stall the live event stream while they were taking a snapshot. Others couldn't guarantee the order of events was correct, and some even required locking tables. Netflix needed a solution that checked every single box, especially not stalling the log and not using locks. That's an absolute deal breaker in a high-traffic production environment.
And that brings us to the really clever part of all this, the watermark solution. This is the algorithm they came up with to merge a full snapshot of a database with the live stream of changes and to do it without any of those problems we just talked about. So think about this puzzle for a second. You've got this massive table, right? And getting a snapshot of it could take a long time.
But while you're doing that, new changes are happening, live. So how on earth do you combine that historical snapshot with the live changes so that the final stream is in the perfect historical order? You can't just pause everything, and you definitely can't let an old value from the snapshot overwrite a newer value from the live log.
Okay, check this out. Here's step 1 of how they solve it. dblog briefly pauses processing the log and inserts a special marker, a low watermark. Then it goes and reads a chunk of data from the actual table. And right after it's done with that, it inserts another marker into the log, a high watermark. What this does is create a super precise window in time, perfectly framed by those 2 markers.
Okay, now this is the genius move. dblog goes back to processing the live log, and for any change that happened between those 2 watermarks, it checks to see if that change affects a row it just read in its snapshot. If it does, it literally removes that row from the chunk it just read. This is the key. It guarantees that the more recent data from the live log always wins.
And boom, there you have it. Once the high watermark finally gets processed, the only thing left in that snapshot chunk is data that didn't change during the window. So dblog then outputs everything in perfect order. The events from before the window, then the remaining pruned rows from its chunk, and then it just continues on with the live events after the window. The result is a perfect, historically accurate stream. It's just brilliant.
Okay, so we've got this beautiful, perfectly ordered stream. But wait a minute. Systems like Kafka and Zookeeper that manage these streams, they're distributed across a bunch of machines. How do they make sure this log stays reliable and consistent? What happens if a server crashes? Well, that brings us to our final foundational layer, distributed consensus.
Distributed consensus is basically a super important algorithm that lets a group of unreliable computers that might crash or be slow, all agree on one single, ordered sequence of events. It's the secret sauce that turns a bunch of faulty machines into a single, fault-tolerant, replicated log, which is exactly what we need for our event stream.
And when you talk about consensus, you're pretty much always going to hear 2 names, Paxos and Raft. Paxos came first, and it's famously difficult to wrap your head around. Raft came along later with a very specific goal, to be just as efficient and provide the same guarantees as Paxos, but to be a whole lot easier for us humans to understand.
And this table really breaks down the main difference in how they think about the problem. Raft is really strict. It says only a server with a totally up-to-date log can even be considered for leadership. This just makes everything so much simpler. Paxos is a bit more flexible. It lets any server try to become the leader, but then that new leader has to do a whole bunch of extra work to catch its own log up before it can do anything. All right, so let's boil this all down. We started with the big problem. Our databases are acting like messy global variables. The game-changing concept is to stop thinking about state and start thinking about an immutable stream of events. We saw how Netflix made this real with dblog and its super smart watermark solution. And finally, we saw how it's all built on a rock-solid foundation of distributed consensus algorithms like Raft and Paxos. And I'll leave you with this to chew on. When you stop seeing your database as just a picture of right now, and you start seeing it as the complete movie of everything that has ever happened, what new kinds of applications, what new kinds of analytics and insights does that let you build? Thanks for joining me.